Коллеги, добрый день.
Евгений Анатольевич, начинаем.
Hello, здравствуйте. İsәнмесез, хөрмәтле кунаклар, дуслар, коллегалар. Меня зовут Вдовин Евгений. Я являюсь проректором по научно-исследовательской работе Казанского государственного архитектурно-строительного университета.
Good afternoon, everyone. Dear guests, participants, authors, and friends. Evgeny has just started conference. Dovin Evgeny is Vice Rector for Research Work at Kazan State University of Architecture and Engineering, and he's warmly greets you here in our conference.
Мы начинаем международную научную конференцию «Социо-техническое и гражданское строительство».
So we start our conference, international conference, scientific conference on socio-technical and construction and civil engineering.
Наша конференция будет проходить на английском языке. Весь диалог онлайн, в форуме, в чате будет проходить на английском языке.
Official language of our conference is English. So all the presentations, all the discussions and comments should be in English.
Модератором нашей конференции будет сегодня Мэри Булганян.
I will be your moderator today. So my name is Mary.
Она является кандидатом филологических наук, доцентом, заведующим кафедрой иностранных языков нашего Казанского государственного архитектурно-строительного университета.
So I have PhD in linguistics. I'm the head of Department of Foreign Languages, associate professor. And I'm here to help you.
Я всем желаю здоровья, плодотворной работы и передаю слово Мэри.
He wishes us successful conference, successful and productive work, and he gives floor to me, and I will give you the floor to others a few minutes later. So we start our conference.
Мэри, пожалуйста.
Okay. As Vice Rector said, we start our conference, and before we start it, I would like to tell you today we're opening our conference with plenary session. As we've mentioned before, it is all in English, and everything will be in English. Before presentations, before our speakers present us their works, their reports, we would like to give the floor to our organizing committee and partners. And the first greeting will be from our rector. He will open our conference. So please welcome Doctor of Technical Sciences, Professor, corresponding member of the Academy of Science of the Republic of Tatarstan, Professor Rashid Nizamov. Rashid Kurbangadevich, welcome.
Thank you. Dear friends, our colleagues, my name is Rashid. I am rector, and today Kazan is the capital of Republic Tatarstan, and Tatarstan is one of the most developed regions of Russia. You know about it, and I think we should thank my colleague Evgeny Vdovin. He is vice rector, and he has organized this conference, and it wasn't easy, but especially in this difficult time, we're working today remotely, and but I think it's not a big problem. We can have new experience, new opportunity, and about 600 people can meet each other, can share experience. I think it's a good way to meet in the future too, but I think a lot of you should come to Kazan, to our university, and it's necessary. We are waiting you. Okay. I have to say today our university is a educational and scientific center, and it was founded 90 years ago. We provide undergraduate, graduate, and postgraduate programs which meet international standards. We prepare architects, designers, construction engineers, and others. Very important for us, integration into the international education space, and there are many international students studying in our university. There are agreements on cooperation with different universities in the world, around the world. And for example, we provide double degree programs in collaboration with University of East London. Hello, Toby. Hello, Peter. Hello, Maria Alessandra. I should say, I have to say, our graduates work as the best architects and studies all over the world. For example, Zaha Hadid firm, Jose Sibilia, Adil Beck, Gordon Briggs, and others. Today, about 20 students trained in the firm's architectural firms. I have to say, we have won a lot of competitions between young architects. And for example, Ayraz Zaidulin and Ruslan Manapov won last year in New York competition. It was named Rooftop Hotel Gardens. It was, I think, a big success for us. And about science, which is science conference, and I have to say we are developing our scientific discoveries today, not in the long time future, not in the distant future, and it's very important today for our region, for Russia. And for example, in architecture, urban construction, and design, there are many buildings in Tatarstan and in Russia, in Kazan, constructed according to the project of architects. For example, in Kazan, you can see Mosque Sharif, Korsten, sport hall, basket hall, and others. We taking a part in the reconstruction of important historical places. And not only in Kazan, for example, in Kazan, we can tell about our successful work in the Kremlin, Old Tatar district, and Sviazhsk in Bulgar settlement. It's famous places, and I think it was good job. And not only in Kazan, for example, we have good successful work in St. Petersburg, main Admiralty, Menshikov Bastion, in Fortress of Petropavlovsk in Petersburg, and others. Malakhov Hill in Sevastopol, and Kremlin Armory in Moscow. It's, I think, a high level of our work. And our urbanists work successfully too. And for example, today, Professor Demich and his colleagues preparing urban planning plan for Nabережные Челны. You know, Kamaz cars, we won competition Dakar, for example, and this is city, and we work here. The main problem for our region, for example, for our Republic Tatarstan, in the field of construction materials, is the lack of cement, steel, and firm coarse aggregate production. and we offer our solutions. We develop our solutions. For example, alternative types of binding materials or modification traditional cement using local raw materials, steel substitution for fiber, for example, and high strength concrete based on the riverside usage without firm course aggregate. There are many problem in road construction too. For example, poor quality bitumen, reduced exploitation period of the roads. And that's why we offer special polymeric modifiers. And in this direction, we were also I have to say about we modify we make modification local raw materials using sulfur, which provide high quality to this local aggregate and others. Building construction, and we develop many construction schemes and industrial and in civil construction. And today, my colleague, Professor Desayapov, will talk about his successful work in this area. But there are in our I can say about in our successful construction. For example, we offered construction solution for temporary roof over during Aqua Championship in 2015. It was in Kazan. You know, two swimming pools were made in the football field. It's very seldom case, and but we did it, and we have we should and swimming pool should have a roof, and we did it. It was isn't easy. It should be cheapest and simplest project, and we designed it. And we are also working successfully in our directions. And my colleagues today, I think, can share our experience in different directions. But I have to say, and I want to say, we are waiting you in our university. We are good guys. We are very happy to see our guests, and I think we will do our best, and you'll be happy. That's why I'm waiting you. We are waiting you. Welcome to our university. Marika Moyevna, hello. It was finished.
Thank you very much, Professor Nizam Rashid Kurbangadesh. Thank you very much for these greetings. And now we go on, and we would like to give the floor to our co-organizer and partner. This is Peter the Great, St. Petersburg Polytechnic University. And we would like to give the floor to Vitaly Sergeyev, Doctor of Technical Sciences, Professor, Vice Rector for Research Work, corresponding member of Russian Academy of Science. Unfortunately, Professor cannot join us now, but he sent his greetings. So his greetings. Dear participants and organizing committee, thank you very much for inviting to participate in this conference. I'm absolutely sure that the level of conference is high and we have prominent participants. I really hope for our further collaboration, and I will happily join you in all your projects. I wish all the best to you in conference. Take care and stay healthy. So that was greeting from Professor Sergeyev. And now the next greetings come from Great Britain. We would gladly give the floor to University of East London, to Doctor of Architecture, Head of Research Programs on History of Architecture, researcher at University of East London, René Taub. René?
Dobry den. Rector
Hello.
and Vice Rector and invited guests. It's my privilege and honor on behalf of the University of East London to speak to you today at the Scientific Conference on Socio-Technical Construction and Civil Engineering organized by the Kazan State University of Architecture and Engineering. It has been my pleasure to visit Kazan several times as representative of the University of East London and to nurture and develop the work we do together for our joint degree. This would not have happened without the full support and determination of my Russian colleagues, for whom I have the utmost respect. Our collaboration began almost 10 years ago, and since then, we have tried to grow our work together. Conferences such as this one confirm the importance of the work we do, of sharing information, technology, and understanding. All of us in higher education are committed to raise the quality and level of professional practice, whether it is in architecture or engineering, in design, which is my area, or technology. These have to work together, and we benefit from working together too, to develop the full potential of our students. Staff and professors gain from this collaboration. Last year, I was extremely pleased to be appointed honorary professor at Kazan, and it is an accolade of which I'm very proud. When the collaborative degree began, we were optimistic as to our mission, which was to benefit the students, help them to grasp global debates in architecture and engineering, and enhance the foundation of learning that Kazan offers. During the time of our collaborative degree that reflects our shared interests, we have hosted a group of students from Kazan in summer schools and brought a group of London architecture students to Kazan for a drawing workshop. Cultural exchange develops from experience and understanding that there is never one way to work, one way to learn, or a single means to build. Each year, I examine the students' work, the Kazan students' work, whether it is economics of building, structural and civil engineering, or architectural design, and am continually impressed not only with the achievements of the students, but also with the dedication and professionalism of my colleagues at Kazan State University. Our task as designers and engineers is to make the world a better place. And in these times of isolation in particular, shared learning, shared understanding, and exchange of knowledge has never been more important. I am always challenged, excited, and inspired by my visits to Kazan, and this time, no less so. It is wonderful to see so many of you, and I very much look forward to hearing our speakers today. Thank you.
Thank you very much, René. That was a pleasure. Thank you very much. And we give the floor to one more professor presenting Great Britain, to Professor Peter James Larkin, Chartered Surveyor, Senior Lecturer in Engineering Surveying at the University of East London, Senior Lecturer in Technology, CAD for Heritage and Building Crafts College. So, Peter, you're welcome.
Oh, thank you, Mary. And hello, everybody. Thank you for taking the time to join us today. My thanks first to the organising committee, the hours they have invested in today's proceedings under what can only be described as unprecedented circumstances. Despite all having to stay away from each other, video conferencing has shown how technology can overcome such obstacles, and in fact we seem to be closer together without even leaving home. With that in mind, we have an interesting conference looking at how technology is changing the way we work. BIM has been the focus of my presentations over the last few years, as much technology has been developing in construction and architecture. We have seen the industry change from paper drawings through CAD and into 3D models that can be shared simultaneously across the internet. We have had computers involved in engineering for a long time now, but new advances help with better design, with simulations to detect clashes, structural analysis to model breaking points, and determine economic scheduling and safe methods of construction, thus minimizing the costs of testing and the problems of getting it wrong. As we can see today, with all of us linking in together from all parts of the world, we can use this technology to our advantage. No longer are we restricted to the weekly site meetings in the site hut when the weather is too bad to work, but we can open our meetings to all the stakeholders wherever they are. We are no longer restricted to using only local companies, as we can tap into the wealth of experience out there in the big wide world. Such collaboration is still in its infancy, with issues such as standards, contracts, time zones, and languages to be overcome, but we will, and it will become routine as confidence grows in the industry. Such technology will affect all aspects of construction, and I see from the topics in this and other recent conferences and publications, the scope of using technology in architecture, construction, and engineering is almost limitless, opening far more opportunities in topics previously not considered. New methods of topographical and measured building surveys by laser scanning and the use of drones start the construction process, creating a virtual 3D model base on which architects and engineers can perform their magic. Parametric modeling, visualization through virtual and augmented reality, project planning, structure analysis directly from the model are tools now available. We will shortly hearing about the importance of obtaining and analyzing the correct data for various foundation designs in engineering projects. Federating models compiled from the contributions of each of the different disciplines are used to keep track of the designs and rectify any faults or clashes. The construction managers then take the designs and turn them into reality with the help of construction techniques. 3D printing using concrete, the use of robots, exoskeletons, and augmented reality through smart helmets are just a few of the new technologies currently available. We have a presentation this afternoon of one of these new technologies, that of the use of spraying by rotating atomizers in the construction industry. An as-built survey provides a 3D model as the basis for the operation and ongoing maintenance once the building or structure is handed over. Embedded electronics, sensors, actuators, and network connectivity enable control of many aspects of the building structure, such as energy use, lighting, and everyday financial control of our assets. This is the dynamic data available through the Internet of Things, which can be used in smart buildings or smart structures and extended into smart cities. Digital construction, as BIM Level 3 will be called, has this dynamic data at its heart. The key to digital twins, smart technology, smart construction, smart buildings, smart structures, and smart cities. We need to be smart. In a way, I envy those students just starting out in what can only be an exciting future in construction. So different now compared to the industry I started all those years ago. I wonder what the industry will become over the next 20 to 30 years. I do know the outlook is good, but it will be different. So those of you already working in the industry, be prepared to adapt. Those of you just starting out, embrace the technology and use it to your advantage. We will be hearing in a moment about a new generation of leaders that are required to meet these challenges. For those of you stuck at home during lockdown, take the time to catch up on your learning and look at what is on offer. This conference today is an excellent place to start. Okay, Mary.
Oh, okay, yeah. Thank you very much, Peter. I'm sorry, I'm struggling with this computer. So thank you very much again for these warm words and greetings. Thank you very much. And we go on, and now we will give the floor to our speakers. But before we give the floor to our speakers, we would like to say thank you to everyone who joined us here in Zoom conference. It's about 140 people watching us here, and about 100 people watching us on YouTube. So thank you very much. So we're ready to start. We will have 6 15-minute presentations on different topics, and if you want, I mean, people that join us here, if you want to ask questions about presentation, you may do it in our chat box, which is on the right of your screens. It should be English, please. So as soon as presentation is over, speaker will answer your questions. If there are many questions, you may have further discussion in our forum that you have already registered for. So the first speaker is Professor of Department of Architectural Engineering, Democratis University of Thrace, which is in Greece, panel member of International Council on Monuments and Sites, UNESCO. Please welcome Professor Alkiadis Prepis. Professor Prepis? Yes. Okay, could you please switch on the microphone? Thank you. Yes. Yes, now we can hear you. You're welcome.
A warm greeting from summer Greece.
Λοιπόν, πρέπει να μπούμε, περίμενε, πες τους να μπούμε να ξεκινήσουμε την παρουσίαση.
I would like to express, first of all, my great thanks to the organizing committee for their honorary invitation and the possibility to participate to this jubilee for Kazan State University of Architecture and Engineering International Conference. I wish to all participants great success despite bans because of the coronavirus. And I am looking forward to meet again in the lovely Kazan all together.
Professor Travis? Professor, can you hear us? Okay, we're struggling with technical problems and trying to solve all this. So you may ask your questions in chat box, which is on the right, and we need few minutes, few seconds, I would say, to solve this problem. Maybe he should restart his Zoom conference or something. Okay. So your questions, maybe greetings, or you may just test our chat box on the right. Send a few words. Okay, he's back. Thank you.
Do you hear me?
Yes, now we can hear you clearly. Okay, we should try number 2.
Can you see the presentation or no?
Sergey should turn on the presentation. Just a second. Okay.
Is it okay?
Yes, we can see the presentation.
Okay, let's start.
Mm-hmm.
The purpose of this presentation is to review the impressions of young Charles Edouard Jeanneret, Le Corbusier, from his journey to the East, and specifically from the part concerning today's Bulgaria and European Turkey, attempting to determine to what extent they have influenced his formative years and his subsequent architectural creation. Sources for this analysis are in principle his sketches, watercolors, and writings, as embedded in his diaries. In order to better understand his personal observations, as well as the cultural and architectural environment young Jeanneret came in contact with, we also use parallel architectural examples from the wider regions he visited. Young Jeanneret set out from Germany in May 1911 at the age of 24. After his first stop in Prague, he traveled through Austria and Hungary, Serbia, Romania, Bulgaria, and Turkey. He continued visiting Greece and Italy, from where he headed back into Western Europe, returning to his hometown in Switzerland in November of the same year. In this trip, he was accompanied by an art student he had met in Berlin, called August Klippstein. Cemeteries were one of Jeanneret's favorite subjects on his journey to the East. He deliberately visited them in Central Europe countries and in the Balkans, and mostly in the capital of the Ottoman East, Istanbul. Negotin Brewery in eastern Serbia are specific architectural compounds with regard to typology and form of diverse commercial structures, meant only for production and storing of wine and brandy, but also of the distilleries and the wells. The old cemetery in Rayats, near Negotin, preserves about 1,500 tombstones, built in the period from the second half of the 18th century and the end of 19th. It is strange that young Jeanneret neglects to comment the traditional architecture of these settlements, nor to analyze the productive activities of the buildings. However, from 2010, the Negotin Brewery is on the tentative list of Serbia to UNESCO World Heritage List. The course taken by the two fellow travelers was not smooth. Started from Bucharest, they crossed the Danube on Bulgarian soil. From there, they continue by train to Veliko Trnovo, from where the railway line reached as far as Gabrovo, and there it stopped. The vertical connection that would cross the difficult passage through Balkan mountains range had not yet been implemented. Therefore, they continue from Gabrovo by post horses and carts, following the winding, steep, and rough road to Kazan Lake and Stara Zagora, and from there continued and reached Adrianople. Veliko Trnovo is a city on which young Jeanneret devoted numerous sketches, studying the interior layout of townhouses and made representative drawings of the city and of its historical quarter. Yantra River winds through and around Trnovo in such a way as to make a position of great natural strength and beauty. Let us go now to analysis of the Villa Schwab, also Villa Turk. The house is located in Le Corbusier's hometown in Switzerland. The villa was commissioned in 1912 and completed in 1916. According to the scholars, the villa is thought to have been built on Oriental style, while its plan shows the effects of Ialis layout, the traditional houses on Bosporus in Istanbul. Additionally, Frank Lloyd Wright's early impact on Jan Jeanneret has already been underlined. However, it seems that there are still elements in this original work that need to be identified and could be further analyzed. Villa Schwab is based on a basic square with two crossed axes. On the ground floor, the central area is occupied by a two-story room. In the resulting cross-shaped shape, the front corner spaces are incorporated as an extension of the living room. This arrangement brings to mind the cross-shaped plan of developed Balkan symmetrical house as it was formed in the wealthy mansions of the Balkans and the Yalis layout in Istanbul. Symmetrical traditional Balkan houses are distinguished by their basic tendency to group spaces around the central living room and to the functional relations among them. The main axis always passes through the lobby, and this rule contributes to the monumental character of the architecture of their interior. The cross-vertical axis acquires almost equal importance thereafter. From compositional point of view, in Villa Schwab, the central space is the lobby, which goes through two floors, as a closed patio, forming a third axis of symmetry, this time vertical, around which closed and open spaces and various surfaces are composed. In Villa Schwab, the central space extends dynamically far to the side antennas of the cross, forming two almost open semicircular spaces. Jeanneret made use of this projecting semi-cylindrical element in his first independent project in 1912, designed for his parents. Scholars highlight only the effect of Frank Lloyd Wright's architecture on these elements. However, it has been rightly observed that the effects from the Romanian Curtisoara fortificated house that he visited are just the same important. A parallel inspiration might have come from the series of windows that grow in a semicircular configuration and in conjunction with continuous semicircular sitting places as found in the lounges of the Balkan Oriental houses. Let us go to an iconic monument from the Bulgarian National Revival period in which we find the same layout of the interior. This is the house and workplace of Dimos Sarafina in Veliko Ternov. The house, for which, however, there is no certain evidence that was visited by young Jeanneret, was built in 1861, a dominant place of the city. The sloping terrain required the building to be built on the street on 2 floors and over Yandra River on 5 floors. The representative rooms are located on the 2 upper floors. The lobby is rectangular in shape, with beveled corners at the end of which are placed doors for the rooms. The dining room is in the middle of them, in a semicircular extension of the lobby, spread out over the wide row of windows overlooking the river. In the layout of the house, the lobby is the central room, which in height goes through 2 floors. On the 5th floor, the ring rooms become an open gallery, decorated with a railing of wooden columns with carved iron rods. Coming back to Villa Schwab, the hermetically closed and straight shape of the spaces at the end of the corridor and in the corners of the square raise morphological questions. In our opinion, here we have the transfer of the element well known from the facades of the traditional Balkan houses, and in particular the closed Sachnesin, but this time inside the living room, from outside inside. Its strange shape testifies to its origin. If this might explain the shape of this overhead structure, then even stranger are the oval windows on the sides of these enclosures, resembling ship's portholes. A possible explanation is the following. This is a construction typically found in wealthy Muslim-populated houses, where it was forbidden for women to appear in front of men with their faces uncovered. The wooden musadra, a closet for the storage of night bedding, is placed at the entrance of the lounge. Its crossing is necessary to access the large room with the fireplace and the decorative ceiling, where guests were welcomed. Above the musandra is the mafil, a space overlooking the room, and when open, is the place for the musicians. However, in Muslim houses, the mafil is often closed and accessed via a small wooden staircase through the musandra from the back corridor. Just there, Muslim women and children used to sit and eat without being seen, watching through windows covered by trellises or around glass openings the men in the lounge celebrating or receiving foreigners, or even the man negotiated for marriage. Έφυγες πολύ. Έχεις φύγει. Σιωπήσου. Εδώ είσαι. Let us remind that the Sultan was able to follow deliberations of the Imperial Council in the divan of Topkapi Palace without being noticed from a window with a golden grille. Πάμε παρακάτω. The oval windows, although a Western Baroque borrowed element, were introduced early into the architectural vocabulary of Istanbul's mansions. Young Jeanneret placed them in a distinctive position on the facades of Villa Schwab without falling it to fit them among decorative wooden trellis, for which Osmanlis were very fond of. Even more, an upper zone of the outer fence wall is covered with glass prefabricated elements, which he designed, giving them the shape of the Oriental apotropaic or good luck charms, used against the evil eye. In a sketch of a house interior of Veliko Ternovo, Le Corbusier is concerned with the wide window panes as a unit that organizes the view from the interior to the outside environment, providing plenty of light inside the house. The communication staircase with the ground floor passes in front of this luminous surface, while next to the staircase and parallel to opening is the work area. This sketch perhaps provides a source to his later works. The balconies at the Marseille's Unité give the occupants of each apartment a space which is essentially an extension of the sitting room in which they can get some air and admire the magnificent view. The apartments, as Marseille, show exactly the same arrangement. The monk cells at the monastery of La Tourette, near Lyon, completed in 1961, are laid out in a similar but more modest way. In another sketch, he analyzes again the relationship between inside and outside spaces, in which the staircase is getting up from the ground floor to the roofed veranda. In Refixelia house in Debar, North Macedonia, the loggia provides the division into individual levels and zones. These are modules that the vernacular house follows typically according to its rural functions. We can note a similar podium with differentiated height in a sketch by Le Corbusier organizing a large opening in a house. Kazan Lake, located near the foot of the Balkan Mountains range, is the center of rose oil extraction in Bulgaria. Kula, the ethnographic complex, preserves some of the oldest houses in the core of the old city. In the country yard, within a garden, is a rural ground floor residence impressive with its functionality and simplicity, providing similarities with the house sketched by Le Corbusier. The attention of young Le Corbusier was drawn on the construction methods and on the form of the vernacular Oriental house of the Balkan Peninsula. And in his sketch, he has accurately depicted many of its basic features. The building represents a typical structural system, comprises assembly of a timber skeleton. The foundations are made of stone and are visible. Well elevated at distances are horizontal beams along the wall. The roof structure is made of timber. Particularly, he notes the presence of the projecting polygonal bay window on the first floor, covered by trellises to protect domestic life from the gaze of strangers. The entrance is through a large door leading to the country yard. A single wooden staircase connects the country yard or the ground floor and the first floor. The first steps are generally made of dressed stone blocks to protect them from moisture and rainwater. We found this detail on the staircase at the central entrance of the elevated ground floor of the Wassenhof single-room houses 14 and 15 designed by Le Corbusier and his cousin, Pierre Jeanneret, in 1926 as a morphological element here. Le Corbusier observes the relation of the street as a public place to the private and closed space of the traditional house. On the streets, the severed facade of the house appears, which, however, on the upper floor shows a tumultuous interplay, the Shachnisim projecting with morphologically rich and slightly organized openings. A small bay window controls the main entrance and protects it in case of emergency. In the developed houses of the later, mature period, the building's main facade displays impressively on the road. Le Corbusier admires the splendor of the great houses called konaks, characterizing them as architectural masterpieces. We would like to stress the resemblance between that house he sketched and Kutev house in Kazanlek, a town where he stayed for 2 weeks, and which was built by the same master craftsman who built the impressive Dimitris Georgiadis house in Plovdiv. Contrary to what has been written about the supposed wideness of the traditional houses that Le Corbusier saw and was impressed of during his journey to the Balkans, it should be emphasized that this condition did never exist to the extent that he found, and much more to the extent that this was admired by his scholars. What comes out of his color sketches is precisely the sense of intense color that has mostly characterized the high-class representative houses in the Balkans. Consequently, it is the Balkan and Oriental tradition of the strong color use that characterize the facades and interiors of houses and mosques where we should look for additional possible source of inspiration for his subsequent searches and applications of vibrant earthy colors in the apartment facades at the Marseille Unité and his later architectural works. Zagora was the biggest town in today's Bulgarian territory, but he was totally destroyed by the Turkish army during the Russo-Turkish War in 1877. Lubovayer was a construction technician, a master designer of the new plan of the city. He prepared as early as 1879, following a rectangular checkboard pattern typical for the major cities in America, actually the ancient Greek Hippodamian plan. During the visit to the city, this plan had basically acquired its new pioneer urban character, which made it completely different from the oriental character of the South Balkan town centers the two friends had visited until then. It is remarkable that the young architect was not impressed at all by the differentiated image of the new Bulgarian city. What impressed him and passed on his notes were the gardens with flowers in some remaining old houses and mostly the first Turkish cemetery he had ever visited. Edirne. On their way to Constantinople, young Zanere and his companion Klipstein visited Adrianople, the capital of the Balkan part of the Ottoman Empire, a big trade center, and the birthplace of Adrianople School in Ottoman architecture. They visited representative monuments, among them Rustem Pasha Caravanserai, for which he made the sketch of the entrance, and Eski Jami. We want to pay attention to the large Ekmeci Hazene Ahmed Pasha Caravanserai, built by the order of Sultan Ahmed I, and the architect responsible for this was the same of the Blue Mosque in Istanbul. The structure has two separate wings connected by a central part. The interior of each wing is quite dark, and it's illuminated by the only windows open to the walls of the narrow sides. The large east wall gives the impression of a heavy curtain, dark curtain pierced by narrow strips of colored light, as it is allowed to pass in controlled quantities through the colorful windows. The overall picture inside the caravanserai is so striking that it immediately gives birth to the idea that the young generation is likely to have noticed the impressive atmosphere of this interior. It is possible that this image came back to his memory when sketching the famous perforated wall in Ronsham Chapel after the whole 40 years. The Ottoman railway line was starting from Edirne. Muratli was a small railway station, but of importance, as from there, a 22 kilometers long road led by the shortest connection from inland to Marmara Sea, to the port of Redestos, the second big city in Edirne Vilayet. Zanere and Klipstein on their way passed by a Turkish chiflik, I will explain it, dominated by a tower house. The property was bordered by a wall all around. The residence was surrounded by a high wall fence consisting of the exterior walls of the auxiliary buildings of the complex. The main building was a big kula, defense tower. The image of the fortified residence impressed young Le Corbusier, who had it drawn and visited the yard interior. A much better picture of what these complexes represented we can acquire from old photographs of identical chifliks existed just in the same area, found in the Russian Army's archives of the Russian-Turkish War of 1877-78. On the first photograph, there are visible the box maculations of supporting corbels of the upper floor. The second photograph provides a closer picture of the only entrance to another chiflik through a gate well protected by a guardhouse. Certainly, both are similar to what young Le Corbusier has seen in his route from Muratlis to Redesto. The chifliks were located near Küçükçekmece Bridge. The second photograph presents the San Stefano chiflik, Piso. The photographs were taken after the Treaty of After the Treaty of San Stefano, July-August 1878, during or shortly after the end of the Berlin Conference, before Russian troops withdrew from the sea. This type of tower houses, surrounded by fortified complex, was connected with a particular type of land ownership and agricultural production that was predominant in the Balkans and in the region of East Thrace during the late Ottoman period, 17th to 19th century. It consisted of a compact tower with nearly square ground plan, comprising at least 3 floors. The thickness of the walls reached to 1.5 meters on the ground floor, a testimony to the insecurity the local feudal landowners felt towards the dependent people who lived and worked in their estate. A large number of these chiefs belonged at that period to high bourgeois representatives of ethnic minorities, Greeks, Armenians, and Jews. Young Jeanneret does not provide any interest of the socioeconomic conditions, neither to ethnic minorities differentiations regarding the buildings attracted his architectural view. From his description, it is certain that Le Corbusier and Klipstein did not continue their journey from the source following the coastal route. So they preferred to get on boat to travel to Constantinople. Villa Savoye is thought to more fully summarize the 5 principles towards a new architecture, as Le Corbusier himself outlined in L'Esprit Nouveau, which he began to formulate in the early 20s. Pilotis, the use of columns to lift the building above the ground plane, the roof garden, the free plan, the long window, and the free facade. However, some of the qualities of his 5-point manifesto could well have been formulated during his early journey to the Balkans. The concept of the prolonged unified window opening widely and indivisibly to the view used to be a constituent element of the Ottoman secular architectural morphology. The oldest surviving example to date of the famous Yali houses is the assembly room of the men's quarters of the Amzadeh Hussein Pasha Yalisi, constructed to house the Austrian ambassador after the Treaty of Karlovitz, as early as the very end of 17th century, supported on wooden pillars over the sea waters. It provides unobstructed views towards Bosphorus through strip ribbon windows placed row at the eye level of a person seated at the window side sofas. Scholars have been long observed the widespread use of elegant wooden pillars in the traditional wooden yalis of Bosphorus, on which the living room extends out of the main volume of the mansion, lifted above the ground plane. The impression is further enhanced in the imperial buildings of the Sultan Palace in Topkapi. The north facade of the Sofa Köşkü provides a brilliant example of the realization by the official Ottoman architecture of both construction methods, which will be among Le Corbusier's modern architecture basic principles. The Stcce arises of the need to build in the correct geometric forms the floor to expand its area and to create conditions of better functional organization of structure and aesthetics of the premises. It also visually connects the house to the street. Extending well beyond the ground floor, a bay window hangs over the street, allowing householders to observe the entire length of traffic through a side windows. The bay window is also of great importance in shaping the importance of architectural picture of the whole ensemble on the street and the city. The houses involved provide first-class examples of projected bay windows in successive rows on timber construction buildings. Similar examples of bay windows should have impressed Le Corbusier in Istanbul as well. Consequently, numerous examples should have influenced him in designing the large-scale projected bay windows for the facades of La Tourette convent near Lyon, and also used the effect of turned sideways windows as bright soleil in the Massey apartment buildings and at the Carpet and Art Center at Harvard University in Cambridge, Massachusetts. In Istanbul, he was very much impressed of the gigantic Ottoman monuments and devotes much of his long stay in Istanbul on visiting and studying them. He stayed about 7 weeks there. I will stop my presentation with this example an angular column which is on a sketch by Jean Jeanneret, showing a Byzantine pillar embedded in the corner of an enclosure of a Muslim religious building, perhaps from Istanbul. There is a similar angular column building just in the north corner of the perimeter wall of Selimiye Mosque in Edirne, which possibly also Jeanneret has seen during his visit to monument. We don't know exactly which of these two monuments represent. They are the works of the great Sinan. The first one was made for the dead son of Suleiman Magnificent, ordered to raise up this first mosque in his memory. And this column points out the very center of Ottoman Istanbul. Strangely, 30 years later, the same architect puts a similar column in the very north corner of his last masterpiece, Edirne. These columns did not have only a symbolical meaning. They had also a high technical use because they were free to move all around. And it was a very bad signal if this moving was not able to be realized. That was a signal of an earthquake, and they had to take care of the building. It was an old technique used in Ottoman architecture, and we see it in another early construction of a mosque in Edirne from the mid 15th century. So what is very important here is the assumption of the angular column perhaps inspired him most likely to place an iron pillar which offers virtually nothing from the static point of view at the corner end of the ground floor building in the Villa Ternisienne, another one of his early works. So the similarity is remarkable. Conclusions. What we have tried to suggest in this presentation is a different interpretation perspective of Le Corbusier's observation and influences through his journey to the East, a perspective that acknowledges the need of a deeper analysis of the specific historical and cultural environment that Le Corbusier came in contact with in the Balkan region. This kind of analysis is necessary in order to understand which elements were selected as more interesting and influenced his later architectural creations, since the Balkans represented a different, more exotic and unknown cultural reality than the one he encountered in the European capitals. It is striking that young Jeanneret was so deep impressed from architectural elements and compositional relations of the traditional houses on Balkan Peninsula that he attempted to introduce them either as synthetic principles for the layout or as individual morphological and structural elements, even in his first architectural creations that followed his return to homeland. However, these elements were introduced as generalist principles with a sometimes mechanical, voluntarist way in an environment completely different from that which gave birth to them, and in many cases under different functioning conditions. It should be noted that Le Corbusier's penetrating and selective look was not dissociated from the wider Orientalist context that had always influenced the Western travelers and scholars and still remains a common way of reading the Balkan area. And it is precisely this fact that has not given the opportunity to him to understand and observe the existing differentiations between the common and the particular, to perceive and understand the architectural peculiarities of the buildings that attracted him, which were largely due to the different local and national cultures of the populations. Young Jeanneret remained completely indifferent to the socio-economic basis as well as of the ethnic composition of peoples in the cities and villages he visited. However, to be fair, on the other hand, we have to emphasize his penetrating architectural glance that will guide him on evaluating and selecting those particular elements from the traditional Balkan and official Ottoman architecture without making any interpretive distinction between them, which will in the following years be among the main cornerstones of his own approach to an axiomatic theory of the re-establishment of modern architecture. Thank you very much for your patience and for your attention.
Thank you very much, Professor Prepis. That was really very interesting and exciting presentation. Thank you very much. We have received, I would say, millions of questions, but we will not ask all of them, just few, because we do not have like much time to ask you all the questions. So the first question is, can Le Corbusier's ideas be used today and how to reform them? And the author thanks for the lecture. So how can his ideas be reformed and used today?
Of course, he was, I would say, he introduced revolutionary ideas for his time. And their method and I would say the way of seeing the relations and the space are guided orders to our studies. What I try to analyze is the influences and what of these influences and why he tried to select exactly these elements and how, and after that, to explain how they were introduced in his later work.
Okay, thank you. And the next question starts with that, but I think it's, what project of Le Corbusier show the most principles of architectural space from the Balkans period? What projects show the most principles?
I have already mentioned that some of the basic principles of the 5 basic principles he introduced are among the elements we found traditionally in Balkan architecture. So to call traditional or even official.
Okay. So, Professor, if you have time and if we may ask you, so questions are in chat box of our Zoom conference. So you may answer these questions there, or you may discuss with the authors in forum. You may have a discussion in forum. So thank you very much for the fantastic presentation and for accepting the invitation to participate in our conference. Thank you. And our next speaker, our next presentation, Sergey, could you please? Professor, thank you. Thank you very much. And we go on with the next presentation. And this is next speaker presents the United Kingdom. So Managing Director of UTest Material Testing Equipment of UK, Baltic and Russia, former International Manager of Cooper Research Technology, Mr. Mark Sergely. Okay.
Well, good afternoon.
Good afternoon. Thank you.
And it's greetings today from Manchester. So we wish we could be in Kazan, but sadly it's impossible today. So I'm a bridge engineer, so I built bridges and designed bridges around the world, and mainly reinforced concrete, and I also a road engineer. So moving from architecture, we're now going to go to an engineering discussion. Sergey, do you have the presentation?
Сергей, у вас есть презентация Марка?
Обновленный нет.
Ну, какая есть. Покажите. Или нам лучше демонстрировать?
Ну, лучше, да, самостоятельно попробуйте, да.
Use mine? Okay. Okay, so today I'm going to talk about the problem with foundations for roads and bridges. One of the problems that I came across many times in my career building was the design was based on calculations and not a great deal of physical importance. So I'm showing pictures here what happens when you get the foundations wrong. And therefore we moved on to some research as to what happened. So typically, as an engineer, we're looking at the modulus of the ground. So people will take a CBR reading or they'll go for a modulus reading. In a road, more than a bridge, it's extremely critical to get the CBR or the modulus correct. Without it being correct, there's technical failures that are impossible to determine. Over the years, axle loads on roads and on bridges have increased significantly. And although the road and to some extent the bridge piers are designed to transfer the load down into the ground, if the design is incorrect of the ground or the subbase, then the load can't transfer correctly. And that's why you see an awful lot of failures in the road, such as rutting, and in bridge decks you'll see cracking and other things appearing. Typically, in Europe especially, we tend to use a triaxial test rather than the physical CBR. We tend to do calculations rather than based on theory. But even then, the resilient modulus has been incorrectly calculated because of the equipment we're currently using to test the various items. In a road, you'll see that creates a rut. In a bridge, it creates problems with the foundations. We used to notice it where especially the bridge abutment met the approaching road. Any settlement that was above or beyond the calculation left a difference between the two levels, and it changed over a period of time. So as an engineer, it became a problem historically of how we could correct this design. There is a machine that was really designed at Cooper Research Technology where it was called an unbound material analyzer. It's basically a machine that, that is designed to replicate real conditions out in the road. It's very simple, it's very small, it's 100 mil diameter, it's bigger than a CBR mold, and it's different to a triaxial mold. And it's putting a universal testing machine with pulses to try to replicate what actually is happening in a road. A CBR is just a single load. A triaxial is also pulses, but the Puma gives a pulses to act as though a wheel is going over it. And these different sizes of machines, depending whether you're using larger material or smaller material. The main difference is that in a CBR mold, the CBR mold is solid. So when you're compressing, the side of the CBR mold restrains the actual movement of the soil. This is not real in the industry. If you go out in the big field, the ground is not restrained. As a quick example I use a lot, it's like an orange. If I press the orange with the orange skin, the resistance I have is very, very large. If I remove the orange skin and press again, it compresses and also expands out. So research was done to make a mold that either expanded that way or that way, depending on the load and the contents of the ground. And halfway down the mold, we have a strain gauge, so we can actually calculate and collaborate with what exactly is coming off this machine. From the initial design, we finished up with the North American Highway System, where they have road research, which is NC8RP. And we worked with them to create a discussion about how to calculate the resilient modulus and compare it with CBR results. We also allowed a correction factor for the friction of the wall of the side of the CBR mold, and we wanted to know if the results we were actually generating were different to a CBR mold or a calculation or a triaxial mold. So the work took us nearly 5 years of research and a fair bit of trial testing and the analysis behind it. The statement from the American system was the resilient modulus is critical, and therefore it has to be correct because it's part of the pavement design and it's part of the bridge design. So with those bases in mind, we had to carry out the project research. Rather than talking about a road and a bridge, for now I just want to talk about a road because the analysis is the same, but the research gives different results, and on a road it's a lot easier to see the results than actually on a bridge deck. We asked a lot of designers, mainly in the United States and the United Kingdom, how they determine the resilient modulus or the CBR value or the ground of our road. And we got a series of different answers. A lot of people told us they use CBR. It's a simple formula they took from a chart and it was on a paper. Some of them also took resilient modulus in the laboratory, which is basically a triaxial test. And it was interesting, some of the designers were using both of them. And yet, when they used both of the answers, they had different results, and that affected the design parameter. I had this problem on a bridge we were designing in Thailand, and we finished up with an engineering team in Thailand working on a CBR, and the design team back in London working on a resilient modulus, and we had a variation that actually caused complication in the initial design. CBR historically is a very, very simple machine. It's just a load cell with a mold. There's an ASTM mold and there's a British Standard or EN mold. Very simple to use, used historically for many, many years. It's one of the first instruments I ever learned to use, but it was not accurate. So a lot of people moved from CBR to a triaxial test because it was supposed to be more real than CBR. Sorry. A triaxial test is, as you can see, extremely difficult to do. It's very complicated to put together. As a nature, it needs a technician that knows what he's doing. CBR test, anybody can really do very quickly. A triaxial test is, by nature, a very difficult test to carry out. With the United States, we were doing a resilient modulus test with the triaxial because they wanted to analyze what was going on, and they were very specific in the pulse loads and very specific of how we actually loaded it. So the ASHTO version and the EN version were, for us, different, and we had to design machines to operate in both. When we finished it, we found that there was a lot of difference between state of the art and practices of what was going on. The resilient modulus is a critical part of a design. A lot of it's been around for a fair period of time. But the biggest problem we had was that although people had the ability to do the tests, they had significant problems with the data, with the personnel training, some of the country requirements, and they found that the tests were not uniformly carried out, even on the same material. So two laboratories would have a different result than on the same material than another laboratory. So we have to analyse what was going on, because we still have these road failures. Of course, we looked at the factors that affect the road, sub-base mainly, and of course the primary factor is of course the applied stress, the lorries, the cars, the traffic that's going over it. But we also spent a lot of time analysing the densities, the fine contents, the moisture contents. And in the colder countries, we had to look at the freeze-thaw effects. Russia especially was going to have the same problem. Not so much here in the United Kingdom anymore, and not so much in the United States with the Florida and everything else. But we had to look at it as a factor. So we did the research behind it. And what we find was that a lot of times the confining stress was never less than 20 kilopascals, which historically gave us a higher modulus of stiffness, rather than if we did it by another method, such as a falling weight. So we had to research into what we could do to overcome this particular problem. Of course, we finished up the question, how important is this unbound layer? So we chose two examples. We chose a thin asphalt, 100 mil thick basically, and we chose a thick asphalt, 200 mil thick. And we varied the base modulus. We were curious of what would happen in the different traffic areas. On the calculations, the predictions came out. We used a base modulus of 1,000 to do the initial calculations. A thin asphalt layer of 100 millimeters with a 1,000 megapascal base layer was very weak. 380,000 passes, and the asphalt was already failing. A thicker asphalt, because of its nature, we could get 20 million, but it was based on that assumption and that calculation. We did the graphs based on the presumptions that we calculated to work out the fatigue life of the thin and the thick asphalt. Clearly, the thick asphalt, the fatigue life is a lot bigger, a lot longer, depending on the stiffness of the modules, because it's twice as thick as an asphalt layer. But we have the curves, and these curves were from calculations. So we wanted to check the overall fatigue life. So we increased the compressive stress, and we calculated the compressive stress against the horizontal stresses using the different moduluses. Don't forget, these were all based on calculations, based on a triaxial test or based on a CBR. So we were curious what the results were, and we finished off being able to plot the graphs. Of course, the thin stuff is very weak. We then took the same base modulus of this time 300, and we wanted to calculate or show what would happen on a road with vertical and horizontal stresses. Vertical stress is traffic. Horizontal stress, when a road is laid, does automatically have some stress inbuilt into it. So the left graph you see there is basically a calculation we used. The right graph, we basically moderated it, and you'll see a negative load because although the vertical stress is zero, there is by its nature an implied load. And the problem with a CBR and the problem with a triaxial test is that's impossible to calculate and impossible to show. So we started to play to see what the answers were, and of course we started to pick up differences between a triaxial test and what was theoretically supposed to happen. So we then put the Puma, the precision unbound material machine, to test. And we wanted to check a thick and a thin to see what actual stress we were creating during the test as against our calculated. And straight away you can see the difference in the vertical stress that the Puma was picking up, because the Puma is no longer bound by the side walls of the CBR, and by the nature of the triaxial test, the Puma is allowed to freely move, and therefore the vertical stresses you could see, especially on the red thin pavement layer, was significant as the load was increased. By the nature of the calculations, we had to build in a factor of friction for the mold. So 0.5 was historically chosen as a nature of the mold. So we needed to check the difference between a mold with a coefficient of friction and an unbound mold such as the Puma. So we finished up with the same graph, but with the Puma results. And you can see from the Puma results, the different than the triaxial results and the different than the calculation results. This became really important in the actual design of the road for us, because using the equation from the triax and looking at the various stress layers, we found that we were using, as a designer, and for me as an engineer that was building it, incorrect data. With this incorrect data, first of all, the abutments at the bridges had a tendency to not be as we initially thought in the design. And as a road, we have, and always will have at the moment until it's corrected, significant failures. So we used gravel in this one. Basically, we were just comparing the triaxial with a hollow cylinder, and we wanted to compare as we went along. When we corrected the stresses, you can see again that the red is the thin pavement, and the blue is the thicker pavement. When we corrected the stresses calculations with the results from the Puma, the results were dynamically and very, very different. Thicker pavement, which people don't theoretically use anymore, was okay. When people went to a thinner pavement, the actual vertical stress that was measured against what was calculated was showing a significant difference, and which would really significantly alter the life of that road. So we had to correct the modulus. And again, in the calculations, we used the predicted load as against the tested load. And we found that the variations were evened out a lot more once we used the Puma. So with the Puma, our predicted load and our tested load became more accurate. Just to compare the modulus, the triaxial test that people use, confinement, is important in the road designers. Suppliers of the aggregates for roads, really, especially on thinner pavements, would like a higher value. So the results here, they prefer to be higher. And from the calculations, they were predicting 157 and 95 in our design loads. But if you look at the test results, the actual modulus was lower. And if you look at the triaxial load, the triaxial was given a higher modulus. So for an engineer designing this road, the data we were receiving from CBR and predicted and from triaxial was actually incorrect. When we used the Puma, we could then change the load actual of the amount of loads against the stress, and we could actually increase, therefore, what was going on in the road and get a very more accurate road. An example of this is in the United Kingdom with railway ballast. We put large stone underneath the railway tracks. The same machine's being used to test the ballast for the new HS2 railway, and they found that the calculation was incorrect, and therefore, in actual fact, they could reduce the thickness of the ballast, on the railway line, which gave a cost saving, especially on 300 kilometres, of a significant amount of money. but they could only do this by taking a real test, not a calculated test. There is a YouTube video so people can watch. That's the machine. A very simple, very small machine. Takes up very little space in the laboratory, but it's a quick way of now doing it. It's a very, very simple test. With the national highways in the United States and their tests, they use this Puma, and I believe in 2021 now it's delayed because of the virus. They are going to put an unbound test as part of the ASTM standards. So we concluded after a lot of research that the modulus of the base payment is important. It depends on a lot of different stress conditions, but when you use an analytical payment design, they have to be correct. And the end results of all the research with all the laboratories were that we had to basically change from an unbound material analysis, not rely on the Puma, because we needed more accurate modulus values, more than you can get on CBR and more than a triaxial. And it allows the road to be designed that the road can actually be either thinner in base, or if needed, thicker, depending on the actual results you were given from the actual particular site. Same issue on a bridge deck, where the bridge was meeting the abutments and the runoff tracks where the expansion roads were. We therefore began to understand why the ground was moving. Very quickly, other people have taken it on further and done research on the Puma. This one was done over in the Chinese zone. Again, they got different loads. They were checking the results that they received compared with the results that were expected, and they got very different results that they needed to repeat. They came out with, of this particular result was, you have to consider the confining pressure when designing the unbound aggregate materials. You can't just rely on a triaxial, and you can't just rely on CBR. That's why roads have a problem at this present moment. I mentioned the railway. This one was done in the United Kingdom with AECOM, Nottingham University, and University over in Palmero, where they used it for rail tracks both here in the United Kingdom, and they're also looking at rail tracks in some other countries using the same type of prediction from the Puma. Again, the paper said, basically, the results are correct, it's reliable, it's easy to use, and it gave a cost saving for the particular industry. Basically, in summary, with an unbound material analyzer, we actually got accurate results now to design the bridge and to build the bridge and the road. It has significant difference when we're designing the durability of the road, because we have real results of every area. And in some recent roads here, we've actually done analysis in different areas. So we don't just say the road is 10 kilometers long, we'll actually analyze every 500 meters, because the nature of ground does change. With the machine, it's very quick to do. The test takes a little over an hour. And we can quickly check as we go along each access of the road and what's going on. We can reduce the road thickness in some cases, or if we have to increase the road. The main criteria in a road, especially, is to design to reduce rutting and stop it. And it's very cost effective to use. As I said, it will be the new ASTM standard. It's supposed to be 2020, but unfortunately the virus has got in the way. So basically it's delayed for about a year. So that's the Puma. Working on it. It's great.
Okay. Good.
Это было очень интересно.
Yes.
Yeah.
One of our users says that it was a very interesting presentation, and I enjoyed it because that was really interesting, and interesting to know and to listen to your presentation. Before I ask you professional questions, I would like to ask you to present your assistant. Nice lady sitting next to you, to the audience. Can you please introduce her?
Where's that?
Okay, she's on the left side.
This beautiful lady is a lady from Kazan, a real Tatar lady, and she's my wife Aida, which is why it's got the name Aida, because she uses my computer more than I do at the moment. So honestly, I'm not Aida's secretary, I'm Mark.
He's my subordinate.
I do what she says. That's the normal system.
Okay.
She's the boss.
Women are always the bosses, I know. Okay.
Nah.
Yes. So, and now we go to questions, and the first question is from Mary. Thank you for great presentation. And how much can your method cut costs of road construction? Can it any cost?
Yeah, I mean, it's like the railway policy. It gives you a real reading. So if the ground and the subbase is suitable, you can actually reduce the amount of material needed, which is a cost saving, which, like on the railway, is significant. The other bit, it may cost more for the road, because if the material is incorrect and not strong enough, you need to increase the road thickness. So the initial cost of the road may increase, but the long-term life of the road is also significantly increased. So therefore, it's cheaper over the long term rather than just looking at the short term.
Okay. Okay. Thank you. Thank you very much. And so next question is about tools. What tools will you advise to use for more exact determination of elastic modulus of the crushed stone layers of the road mat?
The problem is that there's a lot of technology now of people like Tensor and other people are increasing what they're applying. We've done checks where we used the Puma, we've used a lightweight deflectometer, we've also used a heavy deflectometer as well. And it's very much dependent on the type of material. For well-bound material, the Puma's fine, it works well. For larger unbound, we also cross-check with a deflectometer to see a correlation of the data that we're receiving. So we're trying to get an active, real condition of the road. So it depends on the actual material and what else you're going to use.
Mm-hmm. Okay. Okay, I think one more question that will be okay. So one question from Sergey Stepanov, which is surveyor. What countries of the world use Puma, and how are the results justified? Are they statistically and practically proved?
Yeah, I mean, at the moment, the Puma, we first introduced the Puma in, it's been in test since 2012. It's used heavily at the moment in the United States with the NTEC, which is the Nottingham University. We use it over here at the moment in the United Kingdom. Ironically, one is currently at one of your Russian oil companies over in Ryazan. It's used in Australia. It is used in a number of countries now. They still, because it's not a standard yet, the standard will be next year, they still cross-check the Puma with the triaxle results and the CBR results. But everybody at the moment with the Puma will use the Puma results in the calculations because they're the real conditions.
Okay. Okay, thank you very much, Mark. Thank you very much, Aida. We have like a few questions left, so you may discuss all these questions in chat or in forum. And Mikhail says thank you. I say thank you very much for the interesting presentation. And we go on to the next speaker. Thank you. So next speaker is Professor Konstantin Popov, Arizona State University, Director of Russian Branch of Amazon, Arizona State University Leadership Training Program. Okay, we had echo. So, Mr. Professor Popov, yes.
Yes.
Good afternoon, and you're welcome.
So, hello everybody. I'm so happy to see you all online today. So, greetings from Moscow. Although I represent Arizona State University, but I'm based in Moscow, Russia. So I hope you're all healthy and safe today. And I really wondered, why am I invited to this conference? Because I come from a field very different from construction and architecture. So I'm mostly working as a consultant, as a leadership development and communications consultant to corporations, educational institutions, and government agencies. So I thought maybe that was just for the sake of adding diversity component to this conference. And then I thought maybe I might just as well say something valuable too. So as we witness the greatest world economic crisis since the Second World War unfold, and as we see the world economy sinking down, that we better start thinking, how are we going to get over this? And how are we going to revive industries and economies even after we're done with this pandemic? And if you think about it, then you realize that we will need a new generation of leaders, more innovative, more broadly proficient, and capable of innovating in the midst of uncertainty and ambiguity. And in this connection, it's worth looking into the experience of Arizona State University and its approach to building a culture of leadership and innovation. So I decided not to weigh you out with a long 157 slides presentation. So I will stick to one slide today, just to communicate the most important point. So what is ASU today? So it's a public research university based in Phoenix, Arizona. And it's the #1 for innovation in the United States, and has been #1 for innovation for the last 5 years. So it's ahead of Stanford. Stanford is #2, and MIT is only #3. And so it's ahead of Harvard, Yale, Duke, Cornell. So how on earth a university that was hardly known to people outside of Arizona before the year 2002 became #1 for innovation? And besides that, it's in the top 3 in the world for excellence in employee-student connection. So it's in the top 10 in the world for patent. And it's in the top 1% of the world's most prestigious universities. So if you think about it, so the ASU is generating actually economic impact of nearly $4 billion on the gross state product of Arizona, and nearly 50,000 jobs. So just think about it. With what they have, to the best of my knowledge, 119,000 students in 4 state-of-the-art campuses. So how could they do that? So, and the answer is leadership. So it all began with one man who had a dream. So this is the current president of ASU, Michael Crow. But he's a legendary person. He's a visionary leader. He's very innovative and at the same time very practical. He's an adamant advocate for technology. but he started with articulating his vision for what he wanted ASU to become in the future. And so he reconceptualized it in this one sentence: a new American university. So this is what he wanted to create: a new American university, a totally new approach, a totally new paradigm of higher education. So what he meant by that, so he focused on two things, and I think they're very important. Well, first of all, he wanted to demonstrate the highest academic excellence, which is understandable and even self-evident. But besides that, he wanted to focus on accessibility. So he wanted to attract the full breadth of talent that would represent the entire diversity of the communities that ASU is serving. So as you know, accessibility of education in the United States is a big problem. Well, in fact, you know that the best universities are beyond the reach of most people. And this gap between the rich and the underprivileged is just growing. So, and the problem of inequality in the world is also growing. So President Kroes wanted to address this issue. So he wanted to achieve the level of accessibility that anyone who can afford, anyone who can do university level work can afford tuition at ASU. So that was his vision. And in fact, today with they came up with different solutions and grant programs and funding opportunities. So actually today there is no financial barrier. So if you're smart enough and qualified enough, you can enroll at ASU and you don't have this financial barrier. So his vision was to establish a leading global center for interdisciplinary research, discovery, and development. But he also emphasized social embeddedness. So he wanted ASU to be fully integrated into the local economy, so that ASU is not just a welfare organization that the state has to fund, and in fact, the state is funding ASU, but only a small percentage of the operating budget. Well, in fact, just think about it. ASU has a budget of $640 million just for research expenditure. So they're investing a lot, but also, as I mentioned already, about the economic impact, so they're giving back a lot. So they're actually not taking from the state of Arizona, but they're adding value. And this is a remarkable thing about this university and Michael Kroes' approach, how to turn a university that was basically taking into a knowledge enterprise, which is creating value, developing economy, and engaging nationally and internationally. So I just wanted to walk you through the key points that I believe are vital and have been vital to transforming a normal, usual university, just like many others, into an exceptionally model new American university. So the first thing was a change in thinking. So instead of just educating someone to get a degree, let's say in biology or construction and engineering, or let's say business management, he refocused his approach to creating leaders, but with expertise in a particular field. So usually in the university, we just get a degree, let's say in finance, and we prepare ourselves for career in this particular field. But Michael Kroes' thinking was different. He said that in the future, people will not live like this. So we switch careers, the world is too complex, all issues require an interdisciplinary approach. We need to be able to cooperate to collaborate across the broad spectrum of different fields. And we have to be able to work with people from completely different backgrounds. So, and that's why he put this idea as the central core idea that the Arizona State University produces the next generation of innovative leaders who are capable of tackling today's challenges and coming up with creative and innovative solutions. So that, if you will, this became the ideology and the philosophy of this university. And so the second important point, as I mentioned before, interdisciplinary approach to innovation, to learning, and entrepreneurship. One professor explained this to me in this way. He said that it is vital to understand that highly productive and talented people that understand deeply their own field, they tend to be so focused on their area of research that they actually grow boundaries that block other valuable information. So he said three groups are important. For example, innovators, inventors that come up with disruptive ideas, but they do not necessarily understand how to take it to market. So they just think that if they throw over the fence what they have invented, then somebody will pick it up and turn it into a multi-billion-dollar business. But it's not going to happen this way. So somebody has to create a human interface to this, make it user-friendly. So it takes designers, engineers. So they have come to understand that they need to bring people together, people who understand technology, people who understand the market, people who understand design, and have them work together and collaborate together, talk to each other, communicate. So communication is so vital because people who are good at coming up with technological solutions are not usually, well, there are exceptions, but as a rule, they're not so great at communicating these ideas and these solutions. So that's why number three, so they designed campuses in a way that they could create atmosphere that encourages creativity, collaboration, communication among students. And this, of course, helps a lot. And another important point, number four, is that usually we study at the university and prepare for our future career. So in the future, we know that we will have to be working on solving certain problems and challenges. But in today's world, as Michael Crow suggested, so we need to learn by doing, by actually solving actual problems right now, not in the future. And that's why the whole approach of education at ASU is very practical and focused on solutions. But as you can imagine, so this grand vision of turning a university into a knowledge enterprise with a strong emphasis on innovation and leadership will not happen by itself, just overnight. So, and you can imagine that actually the greatest challenge was how to communicate this idea, how to get the whole university united around this ambitious vision. Well, in fact, leaders are not, well, sometimes people ask, are leaders born, or are they made, or are they taught to be leaders? So my answer is usually like this. So a leader is shaped by another leader. So it takes another leader to raise another leader. So that means that students are not going to become leaders if somebody is not shaping them as future leaders. So who are those people who can be mentors and role models and inspiration for the students to aspire to become the next generation of leaders? So the answer is faculty, professors. But if you think about it, professors and faculty, they're so busy with their own research, and especially professors with tenure. So the last thing they think of is how to become an inspiring and innovating leader of the 21st century. They already are very, very busy. And so there was this gap between the President Michael Crowe and his team, his staff, and the students. And so the challenge was how to bring faculty on board, how to turn the faculty and the professors into thought leaders who would channel the energy and creativity and innovative ideas of the President Michael Crowe. And so what they did, so they launched a leadership development program for the faculty and for professors. So, and you can imagine that the first reaction was like resistance. So nobody said, oh my God, I was so happy that this is what I was dreaming about. So I really want to go for a leadership training at my age or with my experience. So there was this resistance, initial resistance. But then there was this leadership, I would say wisdom, how to motivate the faculty and the professors actually to start seeing themselves as thought leaders and change agents. So as you know, professors usually have a lot of things they would like to improve in the university, in the country, in the world. So there are many things actually. I think any professor can name hundreds of things he is not so happy about. And so the Michael Crowe suggested that if you don't like something, if you want to improve something, why don't you launch a project to change it? And at ASU, we call this project to change something, if you don't like it, a leadership action plan. And so bit by bit, they pulled in the faculty and the professors into this leadership engine, as I would say. And bit by bit, they created this consistency from the president's message to the staff, faculty, professors, and students. So this is how this transformation was taking place. So if the faculty, if professors were not so eager to participate, then there would have been this gap between this grand vision and great idea of the president of the university and the rest of the students. So the rubber wouldn't be meeting the road. So we wouldn't be getting anywhere. But since this gap was breached by involved faculty, so this whole transformation started. And today, the ASU is what it is. And of course, as any university in the world, as any big institution in the world that is facing tremendous challenges, still it remains one of the leading educational institutions in the world, one of the leading research universities in the United States. So I believe that to drive technology, to drive innovation, to drive collaboration, it takes innovative leaders as a driving force behind all these changes. And today, as we're facing all the challenges and all the bad news we hear every day, so we have to think ahead. And I believe that every university that is serious about the future has to take this idea seriously. At ASU, we measure the success and effectiveness of the university by the success of its students and alumni. So, and I believe that it would be great if every university, especially specializing in construction and architecture would adopt this idea to educate the leaders of the next generation, more innovative, more creative, more courageous, and broadly efficient, capable of collaborating across the industries and creating this environment where ideas cross-pollinate, where differences melt, and where innovations blossom. So if you are interested in this idea, I advise you to look seriously into the story of Arizona State University. You can go to the website asu.edu. And if you are interested in adding a leadership development component to your universities, for example, or you are interested in adding leadership training courses to your students, so feel free to contact me at my email. I will actually share my screen in a second. Or you can find me on Facebook, which is very easy. Just type my name, Konstantin Popov, and you'll find me. So we can discuss how you can add this leadership development component. And this could be one single element, but that can create a huge difference for your university, for your company, or maybe even for the entire industry. So that was my message. So Arizona State University achieved this level of success by adopting the idea that every professor, every staff member of the university, and every student have to aspire to be innovative and creative leaders in today's world. And with this mindset, I think we have hope. Well, thank you very much for your time. So I understand that my report is not so technical and it's not so grounded in technology, but I think that the message still has a point. Okay, thank you. This is what
kind of borrowed idea of Soviet education. Okay, are you?
Yes.
Okay.
Well, I just wanted to show that one slide that I promised to show.
Sorry, you're welcome.
Okay, I'm good. Hello?
Yes.
So you were saying that ASU stole the idea of...
No, did not steal, no, just borrowed or modified the idea of Soviet education. Yeah, okay, and we had questions in our chat box from one of our leading professors of our university. Mr. Popov, what do you consider to be the main innovations in building education at the University of Arizona, which is Arizona State University? Okay. And our students also participate in patents and grants. And you advocate an interdisciplinary approach. How is that manifested in educational programs?
So, to be honest, I'm not that familiar with details of education in the field of construction and architecture, but the general approach is that, well, there are student centers and spaces that we can call immersive learning environments. And students from different fields, so they get together on project teams that work on specific objective or on a specific problem that they need to draw on the experience and knowledge from students from different fields. So they have tutors that moderate and navigate this process. But the idea is that people from different programs get together And while they exchange ideas and work together on a specific project, they learn on the go. So the idea is it's experiential learning by doing. So I think this is the main approach. Well, maybe this is not a unique approach. And I'm sure that in today's world, many universities have adopted this approach. However, it really takes a lot of effort to make it work. And I believe that at ASU, they have managed that.
Okay, thank you. Thank you very much. One more question. Professor Popov, thank you very much for the interesting report. Let me ask you a question. What forms of organization of the educational process encourage interdisciplinary communication between university departments? Maybe workshops, seminars, and other events?
Well, absolutely, workshops and seminars. And so I know that at ASU, they have modular program. So there are modules focused on specific theme, and actually they go outside of the campus. So they have a retreat. So while they, in an informal setting, work together, and it encourages a free flow of ideas. So this helps a lot. So they actually, the whole idea behind this interdisciplinary approach is take people out of classic, classes, classrooms. So the idea is take them out into the field. So the more you're in the field, the more you interact with the real challenges, the real people, the more it stimulates creativity and innovation.
Okay, thank you. And the last but not the least, there are many questions, but we pick, we have like a number of people here. We picked another question. How does the interdisciplinary approach influence the quality of specialist training? Does it make the quality lower?
Well, I don't see any reason why it should make the quality lower. So I think it depends on how the specialist is actually. It depends more on his attitude. But I believe that interdisciplinary approach should actually be enriching the knowledge and experience of each participant in this process.
Okay, thank you. That was, again, very interesting. Thank you very much for joining us in conference. So we go next, and we go to the next speaker, the head of the Department of Foundations and Basement, Dynamics of Structural and Engineering Geology at our university, the University of Kazan State University of Architecture and Engineering, Doctor of Technical Science, Professor Sayapov. Professor Sayapov.
Under cyclic loading. To sample phase, the calculation accepted design scheme which consists from the pile to loading in ground and the part plate wedge, attributable to one pile. The main stress strain states components behavior of such a cell will match to behavior of the piles as part of flat pile foundations. On the bodies of a cell taken free vertical movement conditions. At the bottom of the cell accepted complete lack of movement. To solve that it is necessary to find the four unknown P1, P2, P3, and tau 0. Using the forces equilibrium equations on the pile and the whole cell, equality movements of ground and at the hell and top piles level obtain a system equivalence. The solution of the system allows to find the settlement value as well as the stress arising in the pile trunk, in the ground under the guelish, and in fine piles under cyclic loading. Limit equilibrium zones, taking into account the rigidity of the pile material determined by the mobilized shear stresses tau n and the shear stress limit diagrams at interaction point, which can be calculated by the formula. Where Cn ground cohesion and under cyclic loading takes in account with by the formula. Depending from the pile links to heel level my account different share of the load, since in the case of increasing the length of the pile, increasing the lateral surface area. Stress occurring in the soil under the raft can be defined by the formula. Stress level appearing at the top of the pile can be expressed as follows. Stress under the heel of the pile can be calculated using it as a formula. Shear stress tau 0 n can be expressed as follows. Flat pile foundation settlements can be calculated by the formula, where SEFN, the conditional foundation settlement, delta SPN, the additional settlement value due to punching piles at the level of the conditional foundation soil. Delta SN settlement due to the pile shaft compression. The conditional foundation settlement during cyclic loading, taking into account the volumetric ground stress strain state, can be determined by the formula. The additional settlement value delta SP due to punching piles is determined by the formula. Settlement due to the pile shaft compression is determined by the laws. Improved methods for calculating ground-based settlement and bearing capacity takes into account change in the stress strain state of a plate pile foundation and increase in deformation stresses and effects, as well as their redistribution between the ground and piles during cyclic loading. Determining the influence of cyclic loading on plate pile foundations in the future will make it possible to obtain more profitable design solution for the building and structures construction on foundation is type. Okay, thank you for your attention.
Thank you very much, Professor Mirsayapov. Thank you for the presentation. That was interesting and exciting presentation. Before we answer all these questions, I would like to say sorry for that internet problems. We have solved them, and now questions for Professor Mirsayapov. Question to speaker. Good afternoon. Thank you for the interesting presentation. How does the draft of the base of the plate pile foundation change with an increase in the amplitude of the cycle? Thank you.
During cyclic loading, there is a decrease in bearing capacity and an increase in settlement. Plate pole foundations with a constant value of maximum load of the cycle.
Did you hear me? I'm sorry.
Yes.
Professor Sapo, shall I repeat the question?
Yes.
What is the difference between on stress-strain state of the subgrade under cycle and static loading?
In static load, maximum loads constant. In cyclical loading, maximum loads change in love sinusoid.
Okay, okay. And one more question. We have just received one question. Why does deformation of the base of the plate pile foundation increase under cyclic loading? Why does deformation increase?
Yes. During cyclic loading, there is a decrease in bearing capacity and an increase in settlement. Plate pile foundation with a constant value of maximum load of the cycling.
Okay, thank you very much. Just a second. One more question, I think the last one. What is the reason for the decrease in specific adhesion of the soil under cyclic loading?
The reason for the decrease in the specific adhesion of the soil under cyclic loading in the destruction of structural and water colloidal bonds in the soil structures.
Thank you very much, Professor Mirsayapov. That was very interesting in spite of nothing. So thank you very much for presentation and for the answers. Now we go to the next speaker. Thank you very much, next speaker is Maria Alexandra Segantini. So, are you here? Just to check if you're here. Maria?
I am here. Yeah.
Okay, great. So, so Maria is reader at University of East London. She is also director and principal CEO of C+S Architects, London and Venice. So, Maria, you're welcome to show us your presentation, to tell us about your presentation.
Yeah. So, let me share the screen. Can you hear it? Can you see it full screen?
We can see number of slides on the left side and one big slide.
Okay.
So slideshow, maybe you should press slideshow. Okay, a bit left, a bit right. Animation, slideshow, just go a bit higher. The red line, right?
Yeah, layout.
Okay, next.
Selection.
No, up. Yeah. A bit up. Red zone, okay, and right.
1 second.
No.
It's hidden in my computer.
Okay.
Okay, now I see it.
Yes, and from the start.
Yeah. Slideshow.
And the first button.
Can you see that? Thank you so much.
Now it's perfect. Okay.
Okay, good. So first of all, thank you very much for this invitation. I'm honored to be part of this Stcce International Conference organized by all our universities. Let me see how this works. Okay. So in the past 20 years, we've quickly shifted from to kind of intertwine infrastructures which were physical to these virtual infrastructures, which we name IoT, and these to collect data, to reduce energy consumption, to improve energy distribution, to kind of streamline trash collection, decrease traffic congestion, and improve air qualities, among many other things, you know. And in London, we are where we are based. We are in the middle of this big hub, which has physical infrastructures such as the London City Airport, the Excel exhibition centers, and many other stakeholders. And we are part of this big evolution. This is our campus. These are the stakeholders to which we are linked and to which we cooperate with research and all these data collection. And obviously our students, but I'll talk about this just a little bit later also, are exposed to all these conditions, where our, student activity goes from very theoretical research agendas to more workshops and labs evolution, which is going every time. But what I'm going to show you is what is the place of architecture in this new framework. So, which is the role of us as architects. And so, as architects, we are anyway building buildings, right? And this is what I am doing most of my life, doing research to create the framework for people to inhabit and be enhanced in these buildings. And I come from this city, which is Venice, just a small premise, which was a smart city at that time because of the commercial connection that it had created through the ports and because of the specific construction that allowed to make an artificial condition, a machine to build, to make life possible in a space where there was no water. The water was collected through the houses and through the small squares that you see around to enhance this possibility of living together. And obviously, this living together goes, as I said, from the very big, small scale of the building to the big scale of the city. And there is a continuity because this campus, these piazzas are wells, for sure, but they are also, places where people are connecting, places where people are creating a sense of community. Going from these examples of our past to the example of the future, what are we working on as a Stcce with research and in the university and as architects? We try to question, in a way, the role of public building. We think that an innovative reconsideration of public buildings and the role within cities and communities can provoke different ways of planting seeds for a better future. So we are working against the idea that sometimes public buildings, because they are monofunctional, they are more private than those privately owned. And this is why we have developed this theory and this approach with this law court office in Venice, with the restoration of a mall, which has become a public space, with a water filtration plant, which has turned into a park, or a piazza, which was designed just for the people of the cinema festival, which in fact became a very beautiful public space where, you know, a small, slight condition of architectural design can create very open and multicultural places for all people. But what I wanted to talk to you about is our special focus about school buildings. So schools are very, very monofunctional buildings. They have been benchmarks in new residential developments in the 20th century, playing a significant role as parallels as churches were in the past, with Dudok's examples that we all know, and with developing the idea of connecting to the landscape, where they first started to go outside with these open air schools, testing new technologies and creating a new relationship between the spaces. And we think also, and this is the famous, very famous Terrani School, this is the reason why we have defined a kind of a school manifesto where we have looked at the schools and their very, very specific program, trying to make them hybrid, open after the school times, energy efficient as manifestos of energy possibilities, and a place where it's possible to engage among the community. We have presented this work with this installation at the 15th Venice Architecture Biennale, invited by Alejandro Aravena. And this is this sculpture is kind of the symbol of these new nodes that we think of, a network that we think are really important inside the communities. And some pictures of this. We have published a book about it and summarized it in this carpet, which was laid under the structure, and which was telling the story that I'm telling you. How did we start it to work? We looked at the schools as they were, and we saw that in fact the very private condition, which is the class, which is the things in black, is a very small percentage if considered in relationship to all the other functions that a school can house. So auditoria, canteens, gardens, special classes for science or art, etc. That, if we consider them openable after the school hours, can become really important community centers. And we have not only defined this theoretically, but we have applied these winning competitions and building up real projects. These real projects were built, and we pushed in order we pushed the Italian government to change the policies for the school buildings, and we achieved that. So at the moment, every school that is built in Italy is built under the regulation of becoming a small hub open to the community after the school hours, and with the special program which is open to that. So, for example, this is another example of a primary school that houses also the public library of the children. So the children at the end of the school, they don't go out, they just other children come in. And it's kind of an interior square for the sprawl city. Intervisibility is also another very important quality for this condition, because the students are kind of looking and copying one from the other. The fact that it is open after the school hours, as I told you, there are a lot of functions, and it's porous. The community can go in. So, for example, in the school that I've shown you before, the community around is organizing. He's using the school in the weekends, and they are organizing parties, barbecues. They're using for the birthday parties. This is another one. This is in Ponzano, near the Benetton factories. And again, it has all the conditions that I told you before. So the gym and the art labs and the labs, the canteen, the square, the garden are all open after the school hours. And the school becomes very porous, very transparent. Everybody is welcome to inhabit it. We have created a small botanic garden also on top of the roof, and the fact that this is a place for the kids to experiment. The classes are kind of also openable outside in these porticos in order to create different conditions of leaving the classes, not only the conventional class, or they can just take the benches and take them outside to do special classes. Then what we have done is working with artists. We have developed a way of engaging with the communities. This, for example, is a small panel that we have elaborated together with Gorni, who is Roberta Gorni is a kids book illustrator, and this is telling the kids how a preheated ventilation is going into the class, and then the air is piped out of the roof. They can see these chimneys in the roof, and they can see that this technology and this way of making a sustainable green roof with preheated ventilation in the class is something that they can touch with their hands. So it's a story, but it's a story which tells also what is physically there. And obviously all the other conditions for sustainability, which are photovoltaic panels, the collection of water to water the garden and the roof and flush the toilets, the portico, which allows a sort of a screen to the sun, but allows also the entrance of the light directly during the winter, and the geothermy, and as well as this preheated air, are all conditions that allows this school to consume like the kitchen of your house. And this was really a good, successful example, especially because the cost was very low. It was in Italy around the cost of construction of social housing. And not only this, what we have done is we have told this story of the building of a school with the construction of the roof, borrowing Lewis Carroll, Alex, and the White Rabbit, and telling myself among the children this story to engage with the community. We didn't present this to the parents. We did present the story of the new school with a small storytelling to the kids, and then they have presented it to the roof. This was one condition of community engagement. For Chiarano, we wrote a theater play, and then let me see if this works. And then we put that in as an act.
una cultura, una storia di un territorio, trasferendola in una nuova contemporaneità che però si nutre anche delle radici.
And we worked with local artists and the kids to present the new project to the parents and to the community.
Inserire all'interno di questa piccola storia che ha raccontato in qualche modo.
Maybe we can go quickly ahead. With this other school, we worked with another small story. It's only 1 minute. And this story was why it's not working anymore? Yeah, and this was a roof that was protecting from the sun. This school did not have the necessity of have any thermal coating because the calculation were making it energetically sustainable just with the thick concrete wall and then a series of other technological like photovoltaic panels, geothermy and other things. But what was really important is that we created some tools for which the community could engage and become a kind of an open school also to kids who were not able to pay the fee because the owner decided to make it a community-friendly school and engage with people asking to offer their time and work to allow the kids to join that community. And that was particularly successful. The pools are quite big. They are preheated so that they can start to swim and to be used in March instead of June, with the similar condition that to the one that I've described before. But this thing of the school, which looks a very simple and building-centered approach, is in fact a possibility, a potential of creating a network, which is already there, to make the city itself through connected and very safe routes, cycling routes or other soft routes, which connecting the schools can make the kids independent, can allow to to specialize these nodes, and maybe also reduce pollution. So this is kind of this, which looks like a very simple and small approach, is in fact impacting the cities themselves. And when we work with our students, I have added a series of student projects which were, in our opinion, quite interesting. We allow them also to have this approach. These are some parking terminals, but which we have hybridized with other functions like malls, museums, etc., in the center of cities like Venice, where we try to create these conditions of overlapping of networks, of overlapping of different infrastructures in order to create, again, a sense of community. The structure here from this student is quite interesting because it was a re-elaboration and reinterpretation of some fundamental structural features of the Gothic in Venice, but retranslated into contemporary modes and forms for this bus hub, parking hub in Piazzale Roma in the city of Venice. You can have a look at the different quality of presentation, models, beam, and the different structures and super detailed design. This is another project which was a hub, a parking hub, an intermodal node between the mainland and the lagoon, and turning out into a landscape project, a museum, and a parking itself. This was the same topic, but developed by another student. And you can see that all these projects go to the last detail of construction. A similar one, so there's a lot of research, a lot of contextual understanding of the community and the potentials of that space, and turning them into this hybrid approach that we develop in research themselves. Our students obviously are exposed to important trips, to beautiful cities, to workshop that allows them to make projects that then are exhibited in the Ducal Palace in Venice. This was a small pavilion that was built by master students. Another one in Milan. In London, again, on-site construction and the construction of a pavilion by other colleagues. Furniture, and also the learning skills of presenting their work and being upfront to show and be proud of their work. Obviously, we apply the BIM technology. This is another interesting project developed in the Guggenheim Museum in Venice and controlled with the BIM, and we expose them to international high top speakers. You can see here Fuensanta Nieto from Nieto Sobeiano or Alejandro Aravena. And this all because we strongly believe that hour is a collective time, that we can talk about data, smart cities, but the center of everything is the users. I've added these gray 3 words to Lina Bobardi's work. And the work is not of a single person. We are teams, we are communities, and only then we can recover the joy of moral participation in work and then in life. Thank you very much.
What is this? Okay, I'm here. Thank you very much, Maria, for that interesting presentation. We have received, I don't know if you see or not, in chat box, we have received a lot of questions. We will not ask all of these questions, but we will ask like few of them. And the first one is, what is the main concept for creating school spaces? How does space and approach teaching method interact? How do these things interact?
So there were, there has been, or there are still researches on the pedagogical approach, that there is a whole history of development of the pedagogical approach, which go from Montessori, Dewey, the school with no tears from Ryan O'Neill. So he wanted to create this relationship where the school was always open and the kids could join in when they wanted. there are a lot of different approaches. These approach affect only partially the layout of the school in a way that, in our opinion, the idea of creating these flexible, intertwined spaces and adaptable to that. So the idea of the hybrid space is a potential to be transformed, to be adaptable, but also to be adaptable in time if these kind of pedagogical approaches or conditions like the one we are suffering now, and the reason why we are not in person, because we are all in our houses. So I think we need to create these buildings which are frames to be filled in and to be as adaptable as possible.
Okay, thank you. So the next question is, so is there a typology of school project, or each project is unique?
Well, thank you for this question. We strongly believe that the architecture is very contextual, but it's not very contextual because so we split this question in two parts. There is a typological approach, and usually the courtyard typology is very interesting because either it being covered or open, it allows to create this central space where everybody is looking at each other, right? And so you create this idea of community through the idea of the courtyard. So yes, there is a typology, but how you design that courtyard, well, that's free and open and related to the plot. If we look at the Renaissance theories of Francesco di Giorgio Martini, for example, they were designing these beautiful theoretical models, Palladio himself, Vasari, and Francesco di Giorgio, and many others, but then they adapted those conditions to the specific sites. And the specific sites is not only the land, the topography, but it's also the climate, the reaction of the building towards different climatic condition, different orientation, the reaction to be a passive condition like the portico that I've described before. So that is the way the typology and the general idea of the school, which is developed usually around courtyard, then becomes specific and it becomes contextual. Architecture is a very local discipline. It's not a generic condition that we can apply wherever. We need to interact with the landscape, with the type of topography, with the construction knowledge of that specific place, and obviously with the climate and the people.
Okay, as you mentioned, like local lands and so on and so forth. The next question is, have local residents been involved in the design process of the schools you showed? Thank you very much for the interesting report.
Yes. All of the things that I've shown, so the theater play and the storytelling, they were part of the initial kind of sketches of the design, so that then we adapted some of them. How we work is that we sit the community together with the different stakeholders around what we call the working tables. Now they are virtual in these days, but they still happen. And we work with the community and with the different stakeholders in order to understand the impact and the suggestions that people who are living in a specific territory for sure will have, and we implement then our projects through this process, which is a process of, I call it negotiation, because I think everybody needs to be involved without, taking away from us the responsibility of design, because that is finally ours. end of research, but it's really interesting how the contribution of even the kids to design is quite interesting in our opinion.
Yeah, children's ideas are quite interesting thing. Okay, thank you very much, Maria. So could you please pay attention to our chat box, because questions like keep coming.
Yeah.
And
but the chat box is it's in the other side, right? Or
on the right side. Wait, can you see the participants of the conference?
Yes. Okay.
It's on the right side.
Okay. Do you want me to answer?
Yes, there are questions like after your presentation, and unfortunately I cannot ask all the questions in person.
Okay. I will try to answer now to all of them.
Okay, thank you very much. Thank you very much. And Professor Prepis has already answered the question. Thank you very much. Alkis, and Professor Mirsayapov, would you please answer the questions as well? So thank you very much, Maria. Thank you very much. And we go to the next presentation. Next presentation is technical. We give the floor to the Doctor of Technical Science, Associate Professor of the Department of Heat, Power, Gas Supply and Ventilation, Professor Safiullin Rinat. Okay, he's here, and you're welcome to present your report.
Good morning, dear colleagues, friends. Let me introduce you to my work. It calls monodisperse spraying technologies in construction, the research of porous rotating atomizers. At the very beginning, I will designate areas of the construction industry where spraying is used. Of course, the main use is dust collecting devices, and of course water spraying in ventilation and air conditioning systems to humidify and cool the air. Each process requires drops of a certain size, but unfortunately the universally used nozzles give a very polydisperse spray. This is clearly visible on this figure and applies to both hydraulic and pneumatic atomizers. In addition, for devices with nozzles, there is a problem of intersection of sprays. You can see this. It's time to switch to monodisperse sprayers, among which the class of porous rotating atomizers stand out. The design is simple: a hollow cylinder of a porous material into which fluid is supplied rotates at the electric motor with high speed. Due to centrifugal force, the liquid is filtered to the outer surface of the cylinder and dropped into droplets from the grains that the whole material contains. Since the grains are almost the same size, the droplets are monodisperse. The ratio of the largest drops to smallest is less than 2. In addition, one atomizer can spray up to 10 tons per hour, which replace dozens of nozzles. Depending on rotating speed, there are several modes of droplet formation in the atomizer. The most important is the mode at rotation speeds of over 20 meters per second, in which droplets are formed on each grain. This mode interests us. The principles of operation of the atomizers have been known for a long time, since the 70s. Already there are designs of devices with such sprayers. Since 1929, an industrial design of the atomizer appeared on the market. The porous cylinder is made of polyethylene granules. The granules have an average size of 200 to 400 microns. At a speed about 30,000 revolutions per minute, it sprays water into drops of 30-50 microns in size. If the spray head is clogged, it can be easily removed and replaced with a new one. However, there is no widespread use of porous rotary atomizers. First of all, because it is not known how to achieve monodisperse spraying. What are the droplet diameter obtained if different liquids are sprayed? How droplets behave in flight? What are their trajectories in apparatus? These objectives were set in this study. So to determine the boundary of the monodisperse spraying regime, it was necessary to solve the problem of the fluid flow rate in the thickness of the atomizer wall. The slides show the statement of this problem. It was found that this speed depends on many factors, on the properties of the liquid, example density, surface tension, and others, on the geometric parameters of the atomizer, granule size, the packaging, wall sizes, and others, and of course on the rotation speed. As a result, a nomogram was obtained to determine the limiting speed of rotation at which the droplets will be formed individually on each grain of the atomizer. The experiments with sprayers of abrasive materials with a grain size of 200 and 400 microns were carried out on the setup shown here by the method of photographing the spray. The determination of droplet diameters showed that when the calculated rotation speed was reached, the spray becomes close to monodisperse. You can see here. In experiments with sprayers made of porous filtering ceramics with grain size of 50 to 60 micron. Droplets were captured in immersion medium. It can be seen that the experiments almost more dispersed droplets of 20 to 30 microns in size were obtained. To answer the question of why droplets from sprays of different materials are obtained in such a way, we performed a numerical simulation of droplet formation on granular models. The granular is spherical. We formulated the problem with the corresponding boundary conditions and performed numerical calculations using the CFD modeling package. Here are the main results. First calculations were carried out in the field of gravity so that numerical and physical experiment could be compared. The figures show how accurately the program simulates the phenomenon. This video shows how a drop on a sphere slowly forms and grows. You can see the fluctuation of its border. Then comes the drop separation and the formation of so-called satellite drops. They always accompany the separation of the main drops. If the grain has a conical shape, then the satellite is very small or not formed at all. We also made a simulation of the printed head with the pushing element inside. Such a design is promising for formation of droplets in viscous liquids or melts. After the first experiments, we performed numerical calculations of the formation of droplets in a centrifugal force field. Here, the simulation results are presented on spheres with a size of 100 and 200 microns at acceleration value from 10 to 100,000 meters per second squared, which is typical for the real work of porous rotating atomizers. As a result, graphs were obtained for determining the size of the droplets depending on the grain size at different speeds of rotation of the atomizer. This is important information for spray technology developers. No less important is the information of the trajectories of droplets in apparatus based on porous rotating atomizers. It is necessary that the drop is fully react with the gas being cleaned. What time will it take? Will a drop evaporate in flight? How far does it fly? These questions are important for designers. These slides show a system of equations describing the movement of a single droplet after it is detached from the atomizer grain. The system was solved numerically, taking into account the evaporation of droplets. The results are shown on slides for devices with an actual flow of gas and for devices with a tangential gas injection. Here are calculated droplet paths depending on the initial diameters, gas parameters, and apparatus dimensions. The time of flight of droplets to the apparatus wall was calculated for different directions of rotation of the atomizer and gas flow. The last slides show the developed designs of atomizers and devices based on them, which can be very promising. In particular, using porous rotating atomizers in eye conditioner, you can increase the controllability of the humidification process and the size of the spray chamber. If nozzles are used, the spray composition is very polydisperse. So a chamber length need up to about 2 meters is usually required. If you use a porous atomizer with almost uniform droplets, then a droplet separator is not needed, and the chamber length is significantly reduced. And the last slide shows the main results of the work, which we would like to inform you about today. Thank you for the attention.
Thank you very much, Professor Sefula. Thank you for the interesting report. Now we know everything. So, questions to the speaker. The first question is it possible to use porous rotating atomizers for atomizing fuel in engines and furnaces? Thank you.
I think it's possible because atomizers from abrasive materials can work in temperatures about 1000 to 2000 degrees. Yes.
Okay, high temperatures. So next question is, how expensive is the atomizer compared to nozzles?
I know that one nozzle may cost about I don't know in pounds. It's may cost 1,000 rubles. I think enough for spraying. But abrasive material, the head abrasive material will cost about 100 rubles. But it is enough for 4 dozen nozzles.
Okay, good. So one more question, as I asked 3 questions. One more question is, does it spend a lot of energy on spraying? Does it spend a lot of energy on spraying?
It's known that hydraulic nozzles spend about 50 watts per 1 liter of water, to spray 1 liter of water, and so on, so as abrasive porous rotating atomizer. That's all.
Okay, thank you very much, Professor Stcce. Thank you for the interesting report. We receive a lot of thanks for the report. And now I would like to give the floor back to our Vice Director for Research Work, Professor Dovin Evgeny. So, welcome.
Уважаемые дорогие коллеги,
Dear colleagues,
мы завершаем наше пленарное заседание конференции.
we are about to finish to end our conference.
Большая благодарность и особая благодарность нашим спикерам.
Thank you very much to our speakers from different universities and
Рашид, Рене, Алкис, Питер, Марк, Аида, Константин, Мария, Ренат.
You cannot see him, but he's here. Thank you very much to all the speakers, Rashid, Maria, Konstantin, Rene, Peter, Renat, and Ilizar.
Видеозапись нашего пленарного заседания мы разместим на сайте конференции.
Video recording of our conference will be on our website.
И на YouTube-канале.
And also it will be in YouTube, so you can easily find it and watch it again, rewatch it.
Большая просьба, те, кто не получил ответа на вопрос, задать их в форуме нашей конференции.
So those people who ask questions, if you have not received answers, please continue your discussion in our forum. That is why we created the forum.
Ну а спикерам, если будет возможность, конечно же, ответить на них там же на форуме.
And we would like to ask our speakers, our honored guests, to answer these questions again in forum.
Наша конференция не заканчивается, она продолжается.
So the conference is not really over. It will be continued.
Она продолжается на форуме.
It will be continued in our forum.
На форуме размещены материалы конференции, и поэтому там будет происходить общение, ознакомление, ну и возможная коллаборация наших всех усилий для реализации своих проектов.
Further discussions and communication will be in forum, maybe further collaboration will be there, and please let's continue conference in forum.
Я благодарю